Let's say we have a finite geometric series, and so we can denote it like this: the sum from n equals 1 to n equals k of a times r to the n minus 1 power. And I'm going to denote this finite series as s sub k. So I'm adding k terms of a geometric sequence together. And if I wanted to expand this out, this would be a times r to the 0th power, which is just ar, plus a times r to the, a times r to the 0th power is just a. Actually, let me just write a times r to the 0 plus a times r to the 1st plus a times r squared. All the way, we keep going, plus a times r to the k minus 2 plus a times r to the k minus 1. This is a finite geometric series. Now I want to figure out if there's some easy way to express what the sum is as a function of k. And to do it, I'm going to do a neat little trick. I'm going to multiply both sides of this equation right over here by our common ratio r. So let's do that. So we have r times s sub k is going to be equal to what? Well, I'll just multiply all of these terms times r. So a times r to the 0 times r is a times r to the 1st. So it's going to be a times r to the 1st. A times r to the 1st times r is a times r squared. A times r squared times r is going to be a times r to the 3rd power. Then we're going to keep going. So let me just be clear what I'm doing. Then I'm just going to keep going. A times r to the k minus 2 times r is a times r to the k minus 1. And then finally, let me make sure I have some space here. Finally, a times r to the k minus 1 times r is a times r to the k. So all I did here is I multiplied all of these terms times r, and you could, one way to think about it, just incremented all of their exponents by 1. Interesting enough. But now what I want to do is cancel out a bunch of these terms. And the way I'm going to do it is by subtracting the green stuff from the yellow stuff. This is equal to that, and this is equal to that. Both sides of this green equation are the same. So if I subtract the right-hand side from the right-hand side and the left-hand side from the left-hand side, I'm subtracting the same thing from both sides. So let's do that. Let's subtract. So we're going to subtract this, and we're also going to subtract this, which is analogous to distributing a negative sign. So let's distribute a negative sign right over here and figure out what we get. So on the left-hand side, we're just going to get s sub k minus r times s sub k. And it's going to be equal to, on the right-hand side, and this is where it gets neat. This is where it gets really neat. We're going to have a times r sub 0, which is really just a. Sorry, not a times r sub 0. A times r to the 0th power, which is just a times 1. So that's going to be a. So this just drops down. This is just going to be a. And then these are all going to cancel out. They're all going to cancel out all the way, so that all we're left with is minus a times r to the kth power. So minus a times r to the kth power. And now we can actually solve for our sum. We factor out an s sub k. We get an s sub k times 1 minus r is equal to this stuff on the right-hand side. And over here, actually, we can factor out an a is equal to a times 1 minus r sub k. And now we just divide both sides by 1 minus r to solve for our sum. Divide both sides by 1 minus r, and we are left with s sub k is equal to a times 1 minus r to the k power, all of that over 1 minus r. This is a very, very, very cool result. Because someone might ask you, what is the sum? What is the sum from n equals 1 to n equals, let's say, n equals 50 of, let's say, 5 times 1/3 to the n minus 1. So in this case, our k is 50. Our k is 50. A is 5. A is 5. Our common ratio is equal to 1/3. And so we can just substitute back into this formula that we just derived to figure out what this sum is. You don't have to literally type all of this stuff into our calculator. You just have to type this thing right over here into your calculator. So this is going to be equal to So in this case, it's going to be equal to a 5 times 1 minus 1/3, 1/3 to the 50th power, 1/3 to the 50th power, all of that over 1 minus 1/3. All of that over 1 minus 1/3. And you could just type this into your calculator and get what this exact sum is, which is a lot easier than summing up 50 terms. It's much, much easier, you can imagine, if this wasn't 50, if instead this were 500. So then this would boil down to this right over there. So anyway, this by itself is cool, and we will build on this to figure out what the sum of an infinite geometric series might be equal to.